AI is becoming part of our lives. It has been used in various areas and it will keep spreading more. However, it is not easy to implement AI in application. To overcome such challenges, Renesas has released AI Applications and AI SDK for RZV series. With these solutions, customers can develop AI application for their business easily and quickly. This video is a tutorial of AI application and AI SDK. It consists of 3 chapters. This video follows the getting started of the RZV AI webpage. This is the flow of the getting started. In this video, we will refer these procedures for RZ V2N. First, we will prepare necessary environments. Let's begin with the hardware preparation. We will start from obtaining the evaluation board. To get the board, go to Getting Started and move to Step 1. Click Board and Software. And select Get RZ V2N EVK. Choose Product Options. Click here. The distributors selling the board and remaining stocks are displayed. Select the distributor and purchase the board. Once you get the board, please prepare these items. This will complete your hardware preparation. Next, let's switch to Ubuntu PC preparation. We will install these necessary software on the Ubuntu PC. First, install the Docker engine. To obtain the environment, go to Getting Started and move to Step 2. And click Docker to navigate to the official Docker page. Type Ubuntu in the search window and please select here. Install the Docker engine as instructed here. Once you have downloaded the Docker engine, install Git on your Ubuntu PC. Open the terminal window. Run the installation command in the terminal. You need to set up your username and email address. The Git installation is complete. Finally, install the bmap tools, which is used to write the SD card image. You have now completed the preparation of necessary equipments and software. We can now proceed to set up AI SDK. Next, we will set up the AI SDK. AI SDK is the software for running AI applications quickly and easily on your evaluation board kit. Renesas provides the AI SDKs for RZV series. This tutorial uses V2N AI SDK. We will first obtain AI SDK. To obtain AI SDK, go to Getting Started and move to Step 3. Select the V2N AI SDK and click on it. Read the disclaimer and click Accept and Download. Once you downloaded AI SDK, let's set it up. Next, install the AI SDK. The AI SDK is installed on the Docker engine. To extract and set up AI SDK, go to Getting Started and move to Step 4 and Step 5. Let's install AI SDK. Create a working directory. Register the working directory path. Go to the working directory. Extract the AI SDK here. Check the contents of the working directory. If all directories and files are generated as shown in the output, the extraction is successful. Then we will set up the AI SDK. Go to the working directory. Install AI SDK by building Docker image. Here the command is different for each device, so choose the one for RZ V2N. Build is completed. Create a new directory for Docker container. Run the Docker container. Here the command is different for each device, so choose the one for RZ V2N. Copy the DRP AITVM runtime for later use on the board. AI SDK is installed in Docker container, which will be used to build the application. You can exit the Docker container by typing exit command. AI SDK setup is now completed. The next step is run the application. Next, we will check that AI SDK has been set up properly by running a sample application. To access the sample application, go to Getting Started and move to Step 6. Then click R01 Object Detection. Here is the sample application. We will try building the application. To build the application, go to Getting Started and move to Step 6. Click here to access the command description. Copy and paste to use them. Let's start. Go to the working directory. Get the application source code from GitHub. The download is completed. Then, start the build environment. Register the environment variable. Go to the source code directory. Create and move to a directory for the build. And build the source code. Here the commands is different for each device, so please select the one for RZ-V2N. The application build is now complete. Check the application build results using the ls command. Once this file is generated, the application has been built successfully. You have completed building the application. In the next step, the Docker container is not used, so please exit the container. Next, you need to deploy the application to the board. To deploy the application, we use the micro SD card. Before starting to set up micro SD card, please note that some procedures are required only when you start using the AI SDK or switch to new version of AI SDK. Regarding the micro SD card, please prepare the one with at least 16 gigabytes of free space. Please note that the process explained here will erase all content stored on your micro SD card. On Linux PC, the micro SD card is controlled by the device file name. In this tutorial, we use SDB. Device file name is assigned by the Ubuntu PC system when it recognized micro SD card. On your system, the device file name SDB may be assigned to other media. If the SDB is assigned to other media, writing to SDB will overwrite the data and may destroy it. In order to avoid system destruction of the media, you must check the device file name of your micro SD card. Now, let's start writing the files to micro SD card. To deploy the application, go to Getting Started and move to Step 7. Click link for RZ V2N. The commands are described here. Copy and paste to use them. Go to the working directory. To obtain the files, extract this zip file. Confirm the extraction results. Please check that these files are shown. Check the device file name of the micro SD card. Ensure that you have not inserted the micro SD card into the Ubuntu PC before running this command. Insert the micro SD card and run the same command again. Compare the result to check the device file name. Here, the micro SD card has this device file name. Renesas provides the SD card image that includes the Linux files and bool toters. When it is written to the micro SD card with bmap tools, a micro SD card is created as shown in this figure. The micro SD card image is 16 gigabytes. To use bmap tools, all partitions must be unmounted. Check whether the partitions are automatically mounted. Here, 2 partitions are automatically mounted. Unmount these like this. We will write the SD card image with bmap tools. Move to the ESD directory. Run this command to write the SD card image. Change dev SDB to your device file name. Writing of the SD card image is completed. To mount the newly created partitions, remove the micro SD card from PC and insert it again. Verify that the SD card image has been written correctly. If the write operation is successful, 2 partitions are created on the micro SD card. Partition 1 named bootloader and partition 2 is root. Next, we will mount the partition 2 and copy the necessary files to it. Create a directory for the micro SD card. Mount the partition to. Change dev SDB to your device file name. Copy the necessary files. Sync the micro SD card to write all data stored in the cache. Now you have completed writing the Linux files and bootloader. The next unmount procedure will be skipped here, because we will continue writing files to partition 2. Next, we will write the application file to the micro SD card. Application directory structure will be like this. The mounting procedure shown here will be skipped because partition 2 is already mounted. Create a working directory on micro SD card. Before proceeding to the next step, the following procedure is required. Start the container. Register the environment variable. Go to the YOLO v3 ONX directory. Download the file from GitHub for model object. Here, the command is different for each device, so choose one for RZ-V2N. Rename the file. Exit the container. Copy the label file. Then copy the model object directory. Copy the application binary. Then, sync the micro SD card to write all data to store cache. After all, check the all files are located properly. Unmount the partition 2. Eject the micro SD card. Change dev SDB to your device file name. Now you have completed the micro SD card setup. Remove the micro SD card. Now let's run the application. First, we will connect the board and all other equipments. Insert the micro SD card to the board. Change the switch configuration. Connect the USB mouse and USB keyboard and USB camera via USB hub. Connect the board to the monitor using HDMI cable. And finally, connect the USB Type-C cable to the power port. Now check the overall connection looks like this. Now we will boot the board. Turn switch 3 on. Then turn switch 2 on. The board will start up. If you see the Yocto on screen on your monitor, the board has been booted successfully. You can run the application. Let's check the monitor screen. Click the icon at the top left corner to open the terminal. When typing to the terminal, please note that the keyboard is recognized as English keyboard. The procedure from here may vary depending on the version. For latest procedure, go to Getting Started, go to Step 8, click here and refer to the README. Go to the working directory. Change the permission of application executable file. Run the application. The application is started. The application detects items captured by USB camera. You will see bounding boxes and respectively each detected item's details. To exit application, press the Super key and Tab simultaneously to go back the terminal. Then press the Enter key. To shut down the board, enter the shutdown command. Verify that the log message is displayed and the screen is blacked out. After the display is blacked out, turn off switch 2 and switch 3 in this order. Then disconnect all other cables. Now you have built and run the application. Besides the sample we have shown here, Renesas has released many other AI applications that are quick and easy to use. AI application can be accessed by clicking AI Applications. AI application are grouped by category. Please select the category and try the one you are interested in. You can use the same procedures explained in this tutorial. If you have any questions or requests, please access to our GitHub and post issues to the GitHub. For more information, please visit Renesas RZ AI Web.